started with the video?
Yes, please.
Okay.
So everyone, I hope that this video will give you a good understanding of the group, and this is really I think, professionally made. And then after that, you can ask me questions as well, of course.
The research focus of the Integrated Power Electronics and Energy Efficient Systems Lab at the University of California, San Diego, led by Professor Han-Fuk Lei, is at the boundary between integrated circuits and power electronics. The focus is on combining the novel converter technologies and novel component designs in order to target many important applications, particularly combining integrated circuits to generate miniaturized integrated power electronics and power delivery, power management with a smart power delivery, and also to design energy-efficient integrated systems. For applications including mobile applications, data center, high-performance computing, soft robotics, automotive vehicles, Internet of Things, and DC home. Integrated circuit designs starts from schematic design and then moves to layout. After fabrication, the chip returns for testing at the lab's test benches, and then it goes to a professional lab to test for industry standards like EMI. Similarly, in power electronics, an idea is first generated, designed, and implemented on a PCB, and then tested on the test bench. To address a particular problem in the industry, the lab is fully equipped with equipment to test power converters for high voltage, high power, and high current applications. This setup is to test a new AC-DC converter architecture that can directly rectify a high AC input voltage to a low DC output voltage without using bulky transformers. On this bench, a new power converter to provide more efficient power delivery for future 5G base stations is being tested. This research work focuses on high performance, efficiency, scalability, high power density, and fast transient response. The laboratory has an advanced solder and rework station for electronic hardware implementations and experiments. Making the study and working environment as enjoyable, comfortable, and productive as possible is a key driver in building the infrastructure in the iPower3Es lab. This includes equipping every graduate student with a height-adjustable sit-stand desk, ergonomic chair, multiple monitors, modern laptop, and individual cubicle. These are some examples of recent research prototypes from the iPower3Es lab that cover power management IC, smart cable battery charger, and 48-volt to 1-volt DC to DC converter for data center with extreme power density larger than 1 kilowatt per cubic inch and current density larger than 1 kiloamp per cubic inch. This is a smart cable battery charger prototype that can turn unavoidable parasitic inductance in USB cables into a useful inductor for power conversion. This is the key idea of the smart cable vision, where a cable can be employed as part of power conversion in addition to power delivery and data transfer. For more information, please visit ece.ucsd.edu.
All right, thank you, Christina, for playing the video.
You're welcome.
So first of all, welcome to UCSD Visit Day, and I hope everyone is enjoying the day so far. And I hope the video gives you a little bit of flavor of what could be part of the research in my group if we have a chance to work together. At this point, I would like to see if any of you have some questions for me. And it can be the question about the group or the department in the environment in general. Okay, so I do know that some of you, some of you like Khaled, we met separately already, and some of you we are scheduling some meeting. Some of you I actually don't recognize the name, so it's likely that it's likely that you are from other groups and you are just interested in some other research groups interest, but you also want to explore my group. You're welcome here, and you should be welcome to ask questions as well if you want. You see, I see that we have some chat. Yep. Hi, Pohan. Yeah, so the question is, can I describe some style for PhD students? So my style of working with PhD students is that first of all, and this is a general advice to all of you, when you go to PhD, you are not anymore an undergraduate students that you are required to work. This is very important. You want to do this. You want to do PhD, so you want to do the thing that you like. Please do not go to the group that you feel tortured of doing the study. PhD is a long-term commitment. This is long-term commitment. I mean, longer than many of the classes that you took before, right? This is at least 4 or 5 years at least. Some people go to 9 years, of course, not in my group, don't worry. We don't keep you that long. But 4 or 5 years, maximum of 6 years commitment here in general, right? So, I said this to my PhD students a lot. If they don't like what they're working on, this is the end of the road. Go to some other group. But if you do PhD, try to choose the topic that you like to do. Try to choose the group that you like to be in. Work with the people that you like to work with. That is very important. Now, how long it takes you to evaluate that, you can, at first it's always, especially in the COVID time, it's going to take some time for you to explore the environment. So give it about 3 months or so, 3 months to 6 months to actually find out all these selections, whether this is right or not. We will actually, for many of you, will actually give the department fellowship. So within the first year, you can easily choose a different group to work with, and you can have some kind of rotation as well. Of course, when you are given a department fellowship or when you give an RA, you are actually sponsored by a certain faculty. So you would be more attracted to a certain group you work with. And I definitely encourage you to spend enough time to explore that group before you change things around. Now, particularly for my group, I don't micromanage my students' time at all. And I believe most, if not all, of the professors here do the same. We want you to like the work, feel self-motivated, and actually do it. Basically, self-motivated means you try to do things yourself. We are advisor. We are not your company's boss. We are your advisor. So we will try to guide you, coach you to do the right thing. We will actually encourage you to do a certain projects. But if you are some certain, experienced PhD students, some students actually bring the project to the group. That is, I would say, very high level senior PhD student often do. If you're first year PhD students, try to set that as a goal, right? You bring ideas to the group. That is very important. As a milestone that you can set, you are about to graduate, right? You become a senior student. In terms of the working style in my group, again, as I said, I don't micromanage students' time at all. But there is certainly some kind of deadline. So the projects, if we have an IC design, for example, we have the project tip out date, right? If you are in IC, you understand what I mean. That means that is the time for fabrication. Every year we just have, let's say, 2 or 3 fabrication times. So if you miss that, you now miss 6 months of fabrication time. So there's that kind of urgency that is imposed on both you and me for the group, rather than just I try to force any students to do something. But any PhD students at this level, I believe that you understand that kind of constraint and urgency. And we will work together. You and I will work together to back calculate how much time that you need to spend on certain things, to have to meet the deadline for fabrication, for example. So that is my style of working with my PhD students. And again, it all boils down to the thing that you like to do. You definitely need to like it to do it. It is not undergraduate students that anymore. You're not undergraduate students anymore that now your professor just take your hands and then tell you that, okay, go to point A, go to point B. No, 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 no. I will tell you that the target is Z. So let's work together. Do you want to propose that, oh, actually, I need to jump over to D and then try to go to Z, right? I can tell you maybe, you maybe want to jump all over to E, for example. So that is the working together style, okay? Not anymore passively waiting for professors to give the solution. Yeah. Okay. So so the question is about the prelim and qualifying exam at UCSD. Very good question, Louis. I believe Louis is from UCLA, if I remember correctly. So it depends. It's actually different style in different universities. For example, I was from UC Berkeley, and then the prelim there was really, really tough, right? The prelim there was really tough. It's actually the gateway for the students to get in. PhD course. So the prelim here is also demanding. You are expected to first present a research work before you go in to answering the questions related to the classes. So you are required to declare 2 classes to answer the questions around to those classes. But first you need to present some work, some research work. So this is actually, I think, a better setup in terms of prelim. Why? Because the prelim is supposed to be a PhD gateway. So PhD is about research. It's not about just classes that you need to learn, right? You are not students anymore. So it must have a portion of that work, that PhD research work in the first 2 years, 1 to 2 years. It depends whether you have master's degree or not. So 1 or 2 years, it shows that you already started working in doing research, and you already started showing that you have a sense of doing research, okay? Then that's why that first part. And these 2 parts are equally evaluated. So if you only have a courses that you learn so well, but you have no projects in research, unfortunately, that is actually not really qualifying for PhD, at least in my group, in the ECS group, okay? So in terms of qualifying exam, qualifying is another level, very significant level to say that whether you actually now is becoming a PhD candidate. That means you are, you know very well what's the path going toward graduation. You have very clear plan. Now it's just the implementation. And on top of that, you may come up with even something new, but you are really, well-versed in your skill set, and you know where your goal is. So that's a qualifying exam. Qualifying exam does not have any classes related. It's just research. And the committee will ask you, very detailed questions on research, advise you maybe some more that you need to do, okay? So how many students pass and, wait a moment, does UCSD recruits large amount of PhD students every year in user exam? No, I believe you are using this model as Stanford model that they accept. By the way, this is how to say, informal meeting. I want to tell you. Normally, I say this very easily in person. I know it is being recorded now, but let me share with you very frankly. This is not a Stanford model that they accept 200 graduate students, and then 100 students definitely know that they would just get master's degree and get out, right? They cannot go on to PhD because there's not enough slots. No, this is not the style at UCSD. We actually recruit the PhD students, the graduate students that we want to recruit and want to finally get the PhD degree. Now, of course, to get to the final PhD degree, there's a lot of milestones, and we work through this together. But the intention is definitely to guide you, to work with you through the full PhD degree. It's not to, like get 50% off or something. Yeah, so about the research group that I have, I believe you watched the video. I have 5 PhD students now. And I do plan to recruit at least one, if not two, for this year. My focus is on at the boundary of integrated circuits and power electronics. So some of you, actually quite a few of you here, have the experience in at least one or both integrated circuits or power electronics. So I welcome you to talk with me more about this. We set up some meetings for some of the students here as well. In terms of the fundings and so on, we have a strong relationship with different companies. You can see it on our website. We have a government funding, and we have funding from some resources like the military as well. So there's a wide variety of funding. In terms of the research topics related to integrated power electronics, let me be very proud to say that integrated power electronics is in every device, every electronic device that we have today. Okay, so you can see, and it's getting just more complicated power management in these devices. Why? Because we want to optimize it more for energy efficiency. So the job prospect is great for integrated power electronics and power electronics, traditional power electronics. It's really good these days, and it's just on the rise. It's unavoidable result, essentially, I can say. Okay. So I know I have 2 minutes left.